This week, the Sun unleashed a huge explosion that hurled a deluge of solar material toward Earth more quickly than forecasters anticipated. On Saturday, a massive plasma arcing loop from the Sun signaled the beginning of the event. Until it swept away and exploded into space, the snake-like filament grew and oozed out of the Sun's surface more and further. Video of the eruption was posted on X, the website that replaced Twitter, by solar scientist Keith Strong, who had previously worked for Lockheed Martin and NASA. Strong tweeted, "The biggest eruption I have ever seen. It covers more than half the Sun, take note." The incident was also recorded by NASA's Solar Dynamics Observatory. You can see the plasma arc building up, then erupting near the center right of the Sun's disk in the time-lapse video footage, which spans several hours. A coronal mass ejection, CME, is the name given to this kind of eruption because it takes place in the Sun's outer atmosphere, the corona. Charged, extremely hot plasma is thrown into space by CMEs, and occasionally, as in the case of this CME, that plasma collides with Earth. The National Oceanic and Atmospheric Administration's NOAA Space Weather Prediction Center, SWPC, predicted that the CME would cause a geomagnetic storm, a severe disruption of the planet's magnetic field that has the potential to knock satellites out of orbit, interfere with radio communications, and even occasionally bring down power grids. On the other hand, these solar storms also produce breathtaking aurora borealis displays that are visible in the middle of the US. The huge filament eruption's CME was expected to reach Earth on Monday night, according to SWPC forecasters. However, about 9 in the morning Eastern Time, a sudden, significant change in the geomagnetic field of the Earth was observed by NOAA sensors in orbit. An estimated 12 hours ahead of schedule, the CME had already arrived. Why was the space weather prediction so inaccurate? NOAA relies on spacecraft to serve as buoys and gather information on the stream of particles streaming from the Sun toward Earth in order to forecast the arrival time and intensity of solar storms. But just one of the buoys is now in a useful location. According to Matt Owens, a professor of space physics at the University of Reading, we only have a single viewpoint of the Sun for the next year or so. It's like playing tennis with one eye closed, we have poor depth perception. Due to the complexity of space weather and the scarcity of space-based sensors, it is challenging to make precise timing forecasts, according to Brian Brasher, an SWPC representative, in an email to Insider. The intensity of the solar storm when it actually occurs is the other factor in the forecast. According to University College London Associate Professor of Space and Climate Physics Daniel Versheren, that is very difficult to anticipate. He explained to Insider through email that the strength of the geomagnetic storm always depends on the direction of the magnetic field in the plasma cloud. If it is pointing in the opposite direction to the Earth's magnetic field, then the geomagnetic storm becomes particularly strong. However, the SWPC correctly predicted the intensity of this CME. It foresaw a weak G3 storm with a chance of developing into a moderate G2 geomagnetic storm. The storm that eventually developed was primarily G2, reaching a G3 peak overnight. According to NASA, this was only the most recent in a string of 22 CMEs that happened in a single week, with 3 of them aiming at Earth. The Sun has been quite active lately, according to Owens. In actuality, the Sun has been increasing its activity for years as it works up to a decadal peak. Initially, experts thought the Sun's peak would occur in 2025, but it now appears to occur around the middle of 2024. More solar storms have been heading our way as a result. This week, a coronal hole, another structure on the Sun, is also beginning to emerge, bringing with it swift solar winds. All of these factors could have combined to produce a very powerful solar storm on another day. The ideal scenario is that approaching storms cause stunning aurora to appear considerably further south than usual. This time, the aurora was seen in places including Montana, Missouri, Virginia, and the UK, according to observers. In the worst situation, which is extremely uncommon, all the factors come together to bring an extremely quick and intense solar storm to Earth. The geomagnetic fields of Earth could be disturbed by this once-in-a-century event, which would be so strong that it could also harm satellites and other infrastructure like power grids. Multiple Earth-directed tsunamis and fast coronal hole wind are all the necessary components for some significant space weather. However, in this case, the elements haven't quite come together to warrant considerable alarm, according to Owens. He continued, although there shouldn't be any major issues for power grids or other infrastructure, there is a good opportunity for some decent aurora during the next couple of nights. However, the next major catastrophe, according to scientists, will be caused by the sun. A significant solar storm would result in widespread pandemonium, from the mass grounding of aircraft to power outages. The largest solar storm to ever strike Earth was known as the Carrington event, so called in honor of the British astronomer Richard Carrington, who first observed it. It was caused by a powerful eruption on the sun's surface that had the same explosive force as 17 billion 1-megaton nuclear bombs, all going off at once. Technology was severely damaged by the massive geomagnetic storm that the Carrington event caused. As global telegraph connectivity broke down, the world went silent. According to History.com, there were stories of sparks coming from telegraph machines, electric shocks to the operators, and documents being lit on fire by the stray sparks. As polar light displays extended far beyond their usual limits, stunning auroras dazzled skywatchers all across the world. According to National Geographic, the southern lights, Aurora Australis, have only been observed as far north as Santiago, Chile, whereas the northern lights, Aurora Borealis, have been seen as far south as Cuba and Honolulu, Hawaii. Many people throughout the world were seeing the aurora for the first time, so they were unsure of what to make of the brighter-than-normal skies. While some people believed that the world had come to an end, others got their day started after hearing the birds chirp, seeing the clear skies, and thinking that the sun had begun to rise, according to History.com. The Carrington event's impacts were still being felt, and the environment was still quite charged when telegraph employees went back to work the next day. According to History.com, it was impossible for employees of the American Telegraph Company to send or receive messages. As reported by Ars Technica, alarmingly, they discovered that they could unhook their batteries and send messages to Portland, Maine, using only the auroral current. And so, what if a solar storm like the Carrington event happened today? According to the ESA's Space Weather Service network, solar storms are rarely a direct threat to human life. However, there is a chance that they could have an impact on safety-critical systems via electromagnetic effects, including space-based communications, navigation, and weather forecasting services, as well as electrical power distribution on Earth. A storm the size of the Carrington event, if it occurred now, is claimed to be capable of causing an internet apocalypse, which would knock out a significant portion of the population and disrupt numerous businesses. The United Kingdom, according to the government's National Risk Register, catastrophic space weather is one of the most dangerous natural hazards, and businesses have contingency plans in place to handle extreme situations as long as they are given enough notice of them. A Carrington-class event today would cause the US alone to suffer damages worth between $0.6 and $2.6 trillion, according to researchers from Lloyd's of London and the Atmospheric and Environmental Research Agency in the US. Given how challenging it is to anticipate space weather, we cannot say with certainty when the next Carrington-level event will take place. We are aware that this has been happening since the beginning of time because, as Live Science reported in January 2022, radioactive particles left behind by a powerful solar storm that pounded the Earth 9,200 years ago are still present in the ice beneath Greenland. According to an earlier study from 2020, much more frequently than previously believed, strong geomagnetic storms happened in 42 of the 150 years prior. A solar storm with a similar intensity to the Carrington event is said to have struck Earth in 774 AD, according to NASA spaceflight. As Barack Obama says, all across the world, Increasingly dangerous weather patterns and devastating storms are abruptly putting an end to the long-running debate over whether or not climate change is real. Not only is it real, it's here, and its effects are giving rise to a frighteningly new global phenomenon: the man-made natural disaster. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.